Day to all, it's Modern Lab right here, and today me and my other co-scientists will be talking about photochemical smog. Photochemical smog, often referred to as summer smog, is a mixture of pollutants that are formed when nitrogen oxides and volatile organic compounds react to sunlight, creating a brown haze above cities. It tends to occur more often in summer because that is when we have the most sunlight. Photochemical smog depends on primary pollutants as well as the formation of the secondary pollutants. A primary pollutant is an air pollutant emitted from the source directly into the atmosphere. The source can be either a natural process such as a sandstorm and volcanic eruptions, or anthropogenic influenced by humans such as industrial and vehicle emissions.
Examples of primary pollutants are 1. Sulfur dioxide or SO2 is an invisible gas with a strong odor. Its main sources are anthropogenic, resulting from the combustion of fuels and the processing of mineral ores containing sulfur. 2. Carbon monoxide is an odorless gas emitted by the incomplete combustion of fuels. The main sources of atmospheric carbon monoxide are gasoline and diesel-powered engines and biomass burning, forest fires, and biomass fuels. 3. Nitrogen dioxide or NOx is fossil fuels combustion, also known as gasoline and diesel-powered engines, is the main source of nitrogen oxides in urban areas. Microbial activity in the soil and agricultural practices, such as the use of synthetic fertilizers, are the main source in rural areas. 4. Particulate matter, the term referring to the solid particles and liquid droplets found in the atmospheric air.
A secondary pollutant is an air pollutant formed in the atmosphere as a result of the chemical or physical interactions between the primary pollutants themselves or between the primary pollutants and other atmospheric components. Examples of secondary pollutants are number 1, photochemical oxidants, result from the photochemical reactions involving sunlight with nitrogen oxides, sulfur dioxide, or volatile organic compounds. They include acids, nitrogen oxide, sulfur trioxide, and ozone. Second is secondary particles, are the result of the condensation of gases, the chemical reactions involving primary particles with gases, and the coagulation of various primary particles. Health effects. Photochemical smog is capable of inflicting irreversible damage on the lungs and heart. Even short-term exposure to photochemical smog tends to have ill effects on both the young and the elderly. It causes painful irritation of the respiratory system, reduced lung function, and difficulty breathing. This is more evident while exercising or working outdoors. High levels of smog also trigger asthma attacks because the smog causes increased sensitivity to allergens.
People with pre-existing health problems such as respiratory diseases are sensitive to ozone children. The elderly and people with poor lung function carry a far greater risk of developing respiratory illness from photochemical smog than healthy adults. Effects on environment. Photochemical smog has devastating effects on the environment. The collection of chemicals found in the photochemical smog causes problems for plants and animals and life. Some plants such as tobacco, tomato, and spinach are highly responsive to ozone. So photochemically, smog can decimate these sensitive crops. Trees and other vegetations, ozone causes necrotic dead patterns on the upper surfaces of the leaves of trees. Ground level ozone also can interfere with the growth and productivity of trees. The effects of smog of animals are also similar to its effect on humans, and it decreases lung capacity and lung elasticity.
Precautions. Take precautionary steps to safeguard against the ill effects of photochemical smog. Generally, photochemical smog is less concentrated in the early morning or evening. Therefore, exercising and planning outdoor activities during this part of the day limits the smog exposure. Emission from the cars and other vehicles are the largest sources of smog. Reduce your daily pollutant emissions by driving less and making use of carpools, and maintaining the car in good condition. Other small actions, such as tightly sealing the lids of chemical products like garden chemicals, solvent, and household cleaners, minimizes the evaporation of chemicals and helps reduce smog.
Switching over to other types of fuels, the sulfurization of fuel gases from coal-fired power plants, expansion of public rail transports, and low-emission application of fertilizer in agriculture are some of the steps which have drastically reduced the level of photochemical smog. And that's it for today's video. I hope you learned something. Thank you for watching.